All right, welcome. This is the code group from requirements to code with AI. Um, my name is John Miller. I'll be your guide for this webinar. I'm a senior software engineer at Code Staffing. I've played many roles in the software development lifecycle. I'm an AI and machine learning enthusiast and an advocate for effectively using AI to write code. Contact information, you can see me on LinkedIn. If you follow me on LinkedIn, you'll get notifications of new things that I've posted or shared. You can also reach me through email at that address. I have a blog that you might be interested in, which is the AI Practitioners blog, where I take because basically the approach of looking at AI from the perspective of somebody that needs to use it to be effective in software development. And the last is a resource that you might be also interested in, which is a little web page that I created using AI first and prompt first techniques to produce a list of relevant AI assisted software development resources. So take a look at those if you have a chance. And let's move on and talk about the agenda. So as I mentioned, this is a prompt first AI first type of a demonstration. So I'll start with a little bit talking about what that means. Then I'll go into an AI-assisted workflow that I've been developing in order to kind of establish a flow for getting started with AI-assisted software development. Then we'll transition into the main body of this talk, which is all about capturing project requirements in such a way that we can utilize them in an AI-assisted software development process. So that we'll talk about briefly what are requirements. I'll show you a conceptual model that I like to use as a source of business rules and business requirements. We'll talk about deriving from the conceptual model workflows that we can then which will describe what the application will need to do, and then finish that up with detailed use cases that will describe the implementation steps that we need to go through in order to be able to implement this application. So along the way, we'll be talking about some chat modes. We'll talk about a product manager / SME type of a chat mode. And a software architect chat mode. We'll discuss, in some detail what a chat mode is. Then we get into some instructions and things like how to create use cases. What are some instruction standards, some prompt standards, and some project instructions that we want to include in our context before we start to generate code. And then we'll talk about some prompts. And prompts that we can use to create use cases or to create the product manager and software architect chat modes, and also to create the project instructions. So what is prompt first development? Basically, it's a methodology that prioritizes crafting prompts and leveraging LLMs to generate code and solutions. So the idea about prompt first, in my mind, is that before you attempt to write some code yourself, you would ask the AI to produce some output. And in many cases, or at least some cases, you'll find that the output that it produces is a little bit more comprehensive than what you would write on your own. And therefore, you can use it as a way of generating ideas on how a particular problem should be solved. And that's really, really useful. And by starting with the prompt first, you get basically a leg up on an implementation. And in some cases, you get an implementation that you can actually use without any further adjustment. So it brings into focus prompt engineering, which is a core skill now for developers, which is how do we craft a prompt that will effectively implement what we're asking the AI to do. I'll go into some techniques that I use in order to build those prompts, and I leverage AI pretty heavily in terms of creating them. And we'll talk about the integration with the large language models, with heavy reliance on AI assistance for the code generation piece. Iterative refinement, continuous prompt optimizations. I'll talk a bit about taking information that we learn from generating code or other objects and filtering that back into the prompts that created them. And then natural language. Prompt first development. The requirements are often expressed conversationally as opposed to hard-coded documentation. And we'll do, I think, a little bit of both in this session. So there's a repository that's associated with this that has all of the examples that I'm going to show today. I pre-prepared all of the examples because it does take some time to execute the prompts and get the actual results. So this will allow us to get through the presentation fairly quickly, as opposed to having to wait for a lot and fill a lot of dead air. If you're so inclined, I would encourage you to fork the repo so that you have a personal copy in your own GitHub account that you can then use to push commits without affecting the original repo that I'm providing. And that'll just be for your benefit to make it a little bit easier to work with the code itself and to actually extend it or improve on it. You can that will happen. If you find something that you really think is important to share with everybody, you can also you can create a pull request and I'll review it. Okay, so that's the repository, and I said if you do a search for the code presents from requirements to code with AI, that'll point you to the repo where you can fork it. All right, let's just talk a little bit about requirements and moving from a requirements to a solution. So, if you were to go to Wikipedia and look up, software development requirements, you'll see a whole list of different types of requirement documentation that you can provide. So the point of this is that we're not going to explore every single possible different type of requirement documentation that you might have access to or be able to create. But more in general, just focus on if we have some requirements documentation, how can we leverage that requirements documentation in creating an application that implements those requirements. And so along that lines, I've kind of come up with a workflow that I think provides a good deal of value in terms of getting to a point of creating a solution with AI assistance, where we start off with actually defining the business requirements themselves. And there's many different ways of defining those requirements. I'll go through some ways that I like to define requirements when I'm looking to build out new implementations. So we start off with those requirements documentation, whatever documentation we have on that, preferably in a text format. And from that, the AI will generate prompts that will transform these requirements into implementation instruction files. And these implementation instruction files act as a guide or guardrails on the implementation itself. So, for example, if we're creating a C# API implementation, we can define in a instruction file exactly how that API should be built and what the coding standards are that it should use when generating code. And by doing this, it really focuses the AI on specifically what you're trying to accomplish and the goals that you're trying to achieve. And that improves the output that you're likely to get. So essentially the idea is the more context that you give the AI, the more likely that you're going to get something that is suitable for your intentions. Now, the reason that you might not be getting what you intended is that you're not providing enough context to the AI, or potentially that you've got too much context and you need to kind of pare it down a bit. But the AI is going to be using those instruction files, and really what it does is it limits the AI in terms of what it can infer from the information that you give it. So that way, you do get you get results that are more suitable and don't involve as much inference as just implementing prompts that are essentially wide open and unconstrained. So after the AI generates these instruction files, and there may be one or more of these instruction files created that describe how this application might be implemented, the stakeholders can then review and improve and approve these prompts that generate these instruction files. So the output of the first step is actually a prompt that tells the AI that you want to generate instruction files for these particular purposes. So it will look at the contents of what you've already provided in terms of direction in terms of the instructions or the business requirements, and then it will produce instruction files that will help you implement something that conforms and implements those business requirements correctly. So after this review, where we as human collaborators will review this and go over these instruction files, the AI will then take that once we finish the review, and it will produce what I'm calling implementation instruction files. And this is actually running the prompt to produce the instruction files that we want to actually take advantage of. And of course, because AI is non-deterministic, and it can make inferences that are not correct and provide guidance that is not what you were intending, it's always a good idea to review the generated output. And I'm saying here we would review those implementation instruction files and see if one conforms to our expectations in terms of what needs to be delivered, and see if there's any errors or gaps or other issues that might cause the AI to become confused or just head down the wrong path or provide output that we don't want. And I'll talk about some techniques for validating that you've got a solid set of instructions and prompts that the AI can leverage. So after those instruction files are reviewed, the AI will use those instruction files to create what I'm referring to as implementation prompts. And these prompts are basically the instructions to actually implement the solution. So we've started off with our requirements. We've generated a prompt to create some instruction files. We then run those prompts to create instruction files that can help guide the implementation that are specific to this project and potentially something that can be used for many projects. And then we would, after reviewing of those implementation instruction files, we would then generate the implementation prompts. And then that will take a look at what we have in terms of the instruction files and the business rules, and the AI will come up with a series of prompts that we can run to start and finish the implementation. So now, once we have actual implementation prompts available, we can then again go through the same review, improve and approve the implementation prompts. So now we're looking at what it's intending what AI is intending to implement through the prompts, and we need to potentially adjust those to either make them clearer in terms of what our intent is, or make sure that it has the information it needs in order to actually produce a solution. And then these implementation prompts, once they're created, the stakeholders could then review, improve, and approve that actual implementation itself. And then once we have that, we can actually go ahead and start to execute the implementation prompts that will produce a solution that we can verify and test. Okay, so let's move on then, and just talking about what project requires consist of. At least in terms of this demonstration, I'm really focusing on business rules, and these are core to any application about what the application is capable of doing and what are the constraints that it needs to observe in order for it to behave properly. Then we have workflows, which are the process-oriented declarations of what needs to be done and how it should proceed. So these workflows would then explain what the actual activities within the application are that need to be implemented. Then we would have on the back end side, or the technical side, a description of the tech stack that we're going to be implementing this in, describing what the database technology we'll be implementing, with the business logic, how that is implemented, how the front end is implemented, all can be described in this tech stack. And then on the architecture side, we can then basically provide some high-level guidance on how we want this application to be implemented. Do we want a multi-tiered application that runs on the desktop? Do we want a multi-tiered application that runs in the cloud? Are we looking for more of an event sourcing, or in addition to the event sourcing would be a CQRS? And in addition to that, we also describe some implementation patterns or other things like that we could utilize. And one of the ones I like to favor when I'm working with AI-assisted software development is taking advantage of vertical slicing and carving up the application into features and implementing those features from the beginning to the end before moving on to implementing additional features. And we'll talk a little bit about that as well. All right, so moving on. So this is an object role model. This is a notation that's been around since the mid-70s. It's highly used in developing applications that are heavily data intensive, and because it has a very rich constraint language that you can use in order to define your business rules in a very precise manner. And just what I'll do is to take a couple of minutes here, and let's review some of the implementation of this of this particular model, and talk about some of the constraints that it applies. So, so the first one I want to talk about is this group of facts here. Let's see if I can do this. No, not quite, but close. And so what this is trying to do is so what this is trying to do is basically show that an academic who is referenced by a employee number is contracted until a date, so which is referred to as by month, day, and year. And so what we're saying is that an academic is contracted to a date, and this purple line here describes that an academic is contracted on at most one date. And so that provides us with a sense of we have an academic who has a contract. That contract ends on a particular day. They also have a fact that's associated with an academic, which is that the academic is tenured. Right. So when you're tenured, you're not contracted into a date. You're basically on staff until you decide to leave. So there's a conflict between these two constraints, in that you really can't play both of these facts at the same time. So you're either contracted until the date, or you have tenure. And this constraint, which is which is called an exclusion constraint, describes that business role quite accurately. So what it would say, since it's exclusion constraint, means that you can play either this role or you can play this role, but you can't play them both. And so it says so effectively this constraint would say an academic is either contracted until the date or is tenured. And that would describe that constraint. So let me clear this up and talk about a different one. Good. And go back to the laser pointer. Another constraint that is interesting is this constraint here, which is a subset. It's not a subset. I was talking about this one here. This is a uniqueness constraint, and what it says is basically that an academic that it works for a department and has an employee name, those two things together provide a uniqueness constraint that describes that academic. So the combination of the department they work in and the employee's name must be considered to be unique and can't be duplicated. The subset constraint I mentioned is here. And what we're saying is that we have a professor who is a subtype of academic. So he plays all the roles that the academic plays, but he also can head a department. And this uniqueness constraint above these two roles means that the professor can head more than one department, and the department can be headed by more than one professor. It works in conjunction with the academic works for a department by saying that if an academic works for a department, they can head that department. So the idea is that the subset constraint says you must play this role working for that same department that the professor is working. That as a professor, you can then head that department. And finally, the last one I want to talk about over here is a ring constraint. Here we have a role where a teacher audits another teacher or is audited by another teacher, and that each teacher is audited by another teacher, but a teacher may audit multiple teachers. And the constraint that we're interested in here is that we want to be able to prevent a teacher from auditing themselves. So we added a ring constraint here on the combination of the teacher and both auditing and being audited. And this ring constraint is an irreflexive ring constraint. And what it says is that if a teacher audits another teacher, that teacher is not audited by that same teacher. And that basically keeps the application from being allowing this a violation of this constraint in the implementation. And so, one thing to think about. Let me move on Let me move on first to how this model was actually created, and let's see if I can find the window I was looking for there. This one here. So this is actually Visual Studio, and in Visual Studio there is an extension for what's called the called Normo, which allows you to basically implement models directly inside of Visual Studio. And so we have a model called Academia, and here's the same model that I just showed you, but it's in the designer. So what's nice about using a conceptual model for defining your business requirements is that the model is essentially has two sides to it. It has a visual side to it and a textual side to it, and those two things are equivalent, which means that the entire model can be verbalized as text, or the text can be visualized by a model. And you can see here by selecting just one item out of this, which is the rating. You can see here that rating, when verbalized, is an entity, meaning that it's not just a list of values, but it's something that has can have some additional meaning to it. It has a reference scheme of the rating number, and that reference mode is the number as well. The data type is a assigned integer, and this is implementation agnostic. It's just basically saying that the data type in whatever the implementation would be assigned integer. And the fact types that this role plays is that that rating has a rating number, which is the reference mode, and that a teacher, which we see over here, teaches a gets a rating. So the act of teaching a class will mean that you can get a rating, and the teaching or teaches portion of it is actually an objectified fact, which says that if an academic teaches a subject, then that act is going to be that particular teacher teaching that subject is going to get a rating. All right, so and this goes to the verbalization goes true for anything. So you can select just about anything out of the model, and it will verbalize that entire selection. And one benefit about this is that all of these facts are atomic, which means that they can be added or removed at your leisure, and it doesn't change the it doesn't have any ripple effects or changes that have to be propagated to other objects. They're atomic and self-contained. All right, so I just wanted to kind of show you how you go about working with an object role model here within Visual Studio, and encourage you to take a look at this technology because it's very powerful and it's great. It really fits well into AI-assisted software development because of the ability to verbalize any part of the model and have AI then understand a great deal about the domain that you're trying to implement because of all of the information that's contained in the model. All right, so let's go from there back to the slides. And on the next slide, talk just briefly about conceptual models. And conceptual models are, one, they're technology agnostic, which means they're not really defining what you're trying to implement. They're defining just the concepts that you're trying to capture, and then those can be transformed or translated into other logical implementations. So, for example, you can easily turn an ORM conceptual model into a database schema, or into a data warehouse schema, or into a class diagram, or into a definition of a user interface, or any other kind of artifact that you want to project this conceptual model onto. Very, very powerful idea, because you can easily change your technologies and re-implement them into different technologies by just having it consume the same conceptual model and implement it, or you can change the conceptual model and then translate that into changes that need to be made at the logical and the physical layer. Other advantages on the conceptual model is that they're very clear. They're very precise in terms of what you're trying to express. The models, the implementation of the model can be validated internally within the model itself, and that some of the ORM implementations will do that. For example, you can provide actual values that you would want the model to understand for a particular value type or reference mode, and it will actually validate that against the model and make sure that you're not providing examples that violate the model as it currently exists. And the opposite is true as well, as you can provide a list of valid examples to the model, and it will derive from that the constraints that you need to implement in order to maintain that or support those kinds of examples. Expressive, I try to illustrate that before, but it's very, very expressive. You can define very complicated and sophisticated constraints on the entities that you're defining, and the model can support it. It can verbalize it, and then that verbalization that can be used to help guide the implementation. By formal, what I mean is that conceptual models can be based on mathematical concepts, and those concepts then can be validated and used as a part of the validation of the model itself. And then the conceptual models, no, just wanted to point out the conceptual models are not a requirement to actually do what I'm suggesting that you do today as far as generating concept or generating files out of business requirements. But I'd like to use them for two reasons. One is that the conceptual model for the academia model is actually a publicly available model. It's not something that I cooked up. I just implemented the model in the Visual Studio tool, and then used the verbalization techniques to actually capture the model as text. So that ability, or those two abilities, I think they make it useful for this presentation in the sense that we don't need to spend a lot of time validating the model. We can actually use the model as it exists and move on towards trying to implement it as software. Excuse me. All right. So moving on then to object role models. It's a type of conceptual model. We're supported by that Visual Studio extension that I mentioned called Norma. You can, if you search for Norma as an extension in Visual Studio, that'll come up and you can install it. Object role models are textual and visual. As I mentioned, the text can be visualized and the diagrams can, the text can be visualized and the diagrams can be verbalized. And it's this verbalization capability that makes it particularly suitable for AI-assisted software development. And that textual representation is in a formal natural language that can be validated by subject matter experts, which is also a good benefit that we get out of having a model that is that can be expressed as natural language. And it dovetails into AI, which also likes to work with natural language. So this is another example of why this is a particularly appropriate approach. All right, so that's the conceptual ORM model portion. But just to be clear, the conceptual and the ORM models don't capture process. They capture basically the information that you're interested in and the constraints about how that information can be manipulated. But in terms of actually how the data is actually manipulated and what happens during the course of that implementation is not defined in the model. But you can actually derive workflows from that conceptual model. If you ask AI to generate workflows that for this particular model, even though the OR model doesn't have any process-oriented information in it, it just has factual data and constraints, AI can do a pretty good job of inferring what the likely workflows are going to be based on just the structure of the data itself. This may not be perfect, but it does help you, jumpstart the process. You may need to add other workflows to the mix, but it will give you a good start. And again, as thinking in terms of prompt first, it's always a good idea to give AI a shot at producing the document or code that you're interested in, and then you can either improve the prompt to produce closer to what you want, or edit the output directly. So here's some examples of workflows that were derived from the actual conceptual model. Promote a lecturer to senior lecturer, promote a senior lecturer to associate professor, promote associate professor to a professor, assign a class to an academic, add a new academic to the faculty, capturing all the required information and allowing the capture of optional information. These are all examples. I'll get into a longer list of these shortly. In fact, why don't we take a look at that now? Let me go to our project. Not this one. Yeah, I think here we go. The same thing. I want the whole thing. All right. Are we close? I think so. All right. So here's the files in our project. This is our the repo that I was referring to earlier. Code presents. So these are all the files in it, and workflows are right here. So let me preview these and then open them up in a new window just to give us a little more space. And you can see this is a markdown file that was created by Copilot, and it's listed all of these as workflows. And so here we have the ones we were talking about earlier about our promoting things. Here's assigning a class academic. Then we have a series of equivalent demotions to move people back down the hierarchy. Remove an academic from the faculty, transfer an academic between departments, update an academic's personal professional information, assign an academic to administrative roles to eligible academics. So this is a pretty good list of things that we would want this application to be able to do. There may be other things that we could add to this that weren't inferred, but this is the place that we would like to put them. We would want to review all of these, make sure that they're accurate, and make sure that there isn't anything that we've forgotten off the top of our heads that we could add to this list. But once we have it, we can then move on to use cases. So let's go and look at that. So use cases or user stories are basically implementation ready pieces of documentation that we can use to actually implement our application. So these use cases define those workflows at a much more detailed level. What I have here is the assign administrative role to academic use case, and only a portion of that I'm displaying on the screen. But it would look something like this, where you have a use case that has a title, it has a primary actor who is the person that's actually doing the work, the supporting actors who actually to help facilitate it, the stakeholders and people of interest about this particular use case. What is the goal of the use case? What is the scope of the use case? What is the level of this particular use case? And if we switch back to our let's close these. All right, we switch back here to the project. Here we can see a whole, all of those workflows have been translated, or we have use cases now have been generated from them. And if we look, well, let's look at this one here. Promote a senior lecturer to assistant professor. We want to do a preview of that. And then we want to do open that in again into a new window so that we can see it. And this gives you a look at what a use case that we've created for this. Now, just to recap, you remember we started off with just that one conceptual model. what I should probably show you before we get too far gone is that here we have the ORM model, which is what I showed you in Visual Studio. And this is what it looks like when it's saved to a file. And it's pretty dense in terms of the information. It's a highly structured XML document. And while it's possible for AI to interpret this model as it is, what I've also done is I've created a markdown file, which that contains some of the information as well as well, let me preview this as well. And you can see that what this is actually the verbalization of the ORM model in Markdown. So here we can see the essential verbalization of the model here, and there's also a text-based version of that same thing, where we're verbalizing a piece of the model. Okay, and so here you get. So these are basically all these are all equivalent representations of the same conceptual model, and we'll be using these. These are what will be used to actually drive the rest of the demonstration process. So basically, or creating the requirements. So to get all the way to the implementation of the or the definition of the use cases, we would start off with a prompt, which is, well, let's just explain these prompts here. The first prompt is a prompt that will create a chat mode, and that chat mode is actually defined up here as the software architect chat mode, so we can kind of get into it. So the idea behind this is that this prompt creates a chat mode. And while we could have created the chat mode by hand, it's nice to have a actual prompt that creates it, because for two reasons. One, it makes it an easy place to go make modifications and then generate new chat modes from that new definition in the prompt. Also, as things change, since we're not actually specifying what that chat mode should be directly, AI has an opportunity to take in new information from its knowledge base and update the chat mode to reflect those new understandings. So this creates this chat mode. The chat mode itself basically just describes how this chat mode, what's the persona, what are the skills that it brings to the table, what are the technologies or tech tools that it's going to use when it's doing its work, and what kinds of things can it actually do. So here we can see that it understands core expertise, maybe architectural styles. Let me just give it some more room here. So we're seeing it will understand monolithic microservices, event-driven, layered types of architecture styles, standard design principles that we would expect a software architect to understand, the quality aspects of the applications that we're generating, the patterns that we would like to be able to support. All defined in terms of the architectural patterns, then the technology stack masteries, all the technologies that we want it to have a firm understanding of, what cloud platforms we would like to use, what are the integrations, what are the integration patterns or technologies that we would like to take advantage of. And then from a modern development context, we wanted to understand cloud native and how to build cloud native applications, as well as AI integration into those applications, how to deal with CI/CD pipelines and monitoring, all important modern development context that we want to make it sure it understands. And then we have information about how the how communication should be handled. And here we're looking for something that's technical and clear. And then the core responsibilities are the things that we want it to be able to do is like system decomposition and service boundary definition, technical stack evaluation and selection, architecture documentation, design review and validation, reference architecture development. So these are all the kinds of things that we want to be able to do. Now, so once we have this chat mode established, this again would go through a design or an implementation review that would likely go through and pare down some of the things that we're asking it to understand. And the reason, well, one reason for doing that is that by you can kind of think in terms of that the chat mode. What it does is it takes the whole knowledge base that the AI understands. So everything it has in it, all of the information that it might have that it has captured in the model, and it tells the AI to focus only on the things that are described here. So that you can think about it as a way of reducing the context and focusing the AI on the context that makes it more effective when we're actually using this chat mode to actually do some work. So, but once it's been reviewed and we've pared this down to only the technologies that we really want it to be focused on, we can actually use that chat mode. And we can, do I see any here? Maybe I need to make a change to where it's located. Don't see. So let me just look at the files. Chat mode dot chat mode. This might be. I'm not seeing it. Interesting. All right, well, I think I'll pass on this for now. We'll come back to it in a bit, but there we go. So, so here we can see that now when we bring up the list of agents, we see the different agents or chat modes that we've defined here. So we have an AI agent expert, which is one that's provided to streamline and enhancing the AI agent applications. We have the software architect one we've just reviewed. And then there is a product manager a chat mode who's focused on understanding what work needs to be done, prioritizing that work, and scheduling that work, dealing with dependencies between different features and the like, and trying to basically structure the application implementation. All right, so we've talked about chat modes, so we can move back to our. We talked about our use cases. So I wanted to go through some prompts. Again, we talked about the prompt for creating the chat mode for the software architect. There is also a prompt for creating the chat mode for the product manager. And then there's a prompt here for creating use cases from workflows. So the idea behind this, let me just open the preview and open that into a new window. And so this is creating use cases. It's basically say create the use cases for the workflows defined in the Zeek management workflows. It tells us that the context is that this is an academic management platform that handles faculty lifecycle management. The system has defined workflows for various academic operations that need to be documented as formal use cases, following established standards. And just to speak in terms of those established standards, we have a use case instruction file, and this basically goes through and describes exactly how a use case should be built. So it talks about this basically the use case template, which a descriptive title. Here we saw the primary actors, supporting actors, stakeholders, the goal, scope, and level, preconditions and triggers, then the main success standards. And so you can see here that this is a fairly comprehensive instruction file with field by field guidance for all the information that it's expecting you to produce, guidance on how to create a diagram for that use case, and some sample diagrams for that. An example use case, so that you would see, so that it has some understanding about what it's actually trying to produce. A checklist for authoring a use case, naming conventions, some tips, and finally the acceptance criteria for a new use case. So again, the idea here is that now that we have use cases that we've defined, or workflows we defined, we could then run this prompt and tell it to create use cases for the workflows that we've already defined. So kind of going back to the major theme is that we start off with one document effectively, which is the conceptual model. We derive from that a list of workflows. We derive from that a list of use cases, and then we can then start to talk about how we would go about implementing those use cases. All right, so let's go back and then talk about the architecture and tech stack portions of this. One of the things we can do is we can invoke the software architect chat mode, and we can ask it for recommendations on how to implement this particular application, and it will suggest applications or architectures that it thinks are appropriate for this particular application. And you could also ask it to make recommendations on a tech stack. And so here you can, essentially say, tell me, based on what you know about this application, what you think it should, what the application, how it should be built. And of course, you don't need to take those recommendations, but sometimes it's good to see, what another what the AI actually thinks you should recommend, and you can even use different models to see how different models would recommend potentially different technologies, and you can then use those recommendations to decide on a particular architecture or tech stack. You can also specify things like you want this to be an AI first application. An AI first means that if there's going to be AI components built into this application, for example, we might want to see, or there might be opportunities in our application to capture some of the business logic as prompts, and then execute those prompts as opposed to having hard-coded implementations. And then we might get better results out of having an AI first application, which means that we're thinking about AI first. We're thinking about how to invoke AI and utilize AI in the application before in the early stages of the application, as opposed to bolting it on at the end, right? So, and you can even ask AI to say, suggest how this application could be built AI first, and it will then look at what it has in terms of context and make suggestions about where you might be able to leverage AI in the actual implementation. So that's a little bit outside of what my focus is here. I'm basically building an application using traditional technologies, but it's good to be able to think in terms of AI first. And if you're interested in examples of AI first and prompt first, I have an application I can show you. Let me just track it down. There it is. All right, this is ai-resources.codemag.com, and this is a page that I created using AI first and prompt first techniques. You can get to the implementation down below here by saying I'm just going to view this on GitHub. You can also fork the project if you want to actually take a look at what it takes to implement this. But the basic idea behind it is that it uses AI to go out and build a list of resources for AI software development. It then evaluates those resources on 7 different criteria. And whatever the highest criteria is, which is here, it's looking at security vulnerabilities for a security engineering book. And it's scoring that as a 95 is one of the top things here because it's very strong on the security side of things. Here we have a different book, which is Clean Code. Its specialty is maintainability and documentation. It's not as good here with security as the other book, so you can kind of use this as to focus on particular types of technologies or techniques. And here you can see an OWASP one, and we would expect that to be scored pretty high on the security side of things, and it is. So these are all just different resources that the AI found. It then produced a link to the actual resource itself. It has here a little blurb that kind of condenses what this resource is all about, so you can get a sense of that. So it produces all of this, all of these resources and outputs it. And this allows you to actually use it. And an additional thing it does is it actually does an analysis of the content of this week's extraction. It's only I run the prompt once a week and update the page once a week based on that, and it tells you a good summary of actually what's in this week's implementation, and also provide some of these links down below to talk about how to contribute or report issues or fork the project. So anyway, this is a good example. I would suggest going and looking at the repo behind it and take a look at how I'm using AI to actually produce this page and workflows to actually schedule the execution of the AI. All right, so let's move back to our architecture and tech stack. We talked about that. So moving on then to the next page, this pretty much wraps up our presentation for today. For a free subscription to Code Magazine, which is one of the basically the longest currently running coding magazine in existence. So you can use this URL or this QR code to get a free 1-year subscription. Encourage you to do that. And if you have any questions on this presentation, I would suggest you go back here and just to basically contact me through any of these methods, and I'd be happy to clarify anything that I've said or point you to things that you might find to be interesting. So with that, I would thank you for your attention, and I wish you luck in your AI journey.